Hello everyone. I just opened the ChatGPT and it is saying what's on the agenda today. In the agenda today is to learn about a machine learning algorithm or AIML algorithm called random forest. So I'm sitting with a couple of students here. Nobody knows, including me. I don't know what is random forest, but the idea is I want to make this video how to use the modern tools that are available to us, not only ChatGPT but other tools also, to learn about this thing. Okay, so we'll get started. So I will say hi. Uh, I want to learn about random forest. Uh, can you help me? So we get started like this. We just start slow and simple. So it is giving, again, I repeat, I also don't know anything about random forest except that it is one particular learning method. So here, let's see. Uh, Classification and regression. It builds multiple decision trees during training and merges their outputs to make predictions that are more accurate and stable. Okay, so already this is interesting. So I've heard about decision trees. So obviously, forest means multiple trees. So one decision tree may give one result and other decision tree may give other result, and it is going for merging the outputs and making predictions that are more accurate and stable. That means individual decision tree is less accurate and less stable. In that case, we go for random forest method. So that is something. So handle both classification and regression problems, reduces overfitting compared to yeah, this is what we were just discussing. Works well with missing data and non-linear relationships, can handle large data sets with higher dimensionality. See, this is saying okay why, and then I'm reading, but then unless I verify it with a proper thing, I will not accept it. That means whether it really works with classification and regression, I need to verify. Whether it really produces the overfitting problem, I need to verify. Whether it, all these things. That is all in today's agenda. We will do that in future. So how it works conceptually? Okay, random subsets, train the decision tree, feature randomness, multiple trees, aggregation, and all these things. Example use case: predicting customer churn, credit scoring, disease diagnosis, power load forecasting may be relevant to your domain. So already ChatGPT knows that my domain is in power, so that's why it is asking like this. Key parameters: number of trees. Okay, whether you want 100 trees or 200. In fact, I think now somebody says, "Sir, I have applied random forest. I can ask how many trees did you use?" Without knowing anything, I can now ask some interview questions. Maximum depth of each tree. Number of features considered in each split. Maximum samples. Okay, so good. So criteria, Gini, entropy. Good. Oh, I was about to ask, please give me Python code, but without me asking only, Python code is been given. Okay, so let us see. What is there in the code? Random forest classifier. Uh, yeah. So, but what about the data? Test train split, zero point 0.3 test size. See, load. I think this function load iris will be loading the data. Training model, it is training. So, number of trees, maximum depth, random state, then modeling, fitting. So, pros and cons, high accuracy. Okay, we'll come to know. See, first thing what I'll do, since a Python code is given, blindly I will copy and paste it and check. So for that, I need to go to Colab. So you go to this Google Colab, and then of course you can run the Python code in your local system also. I'm using this one, this thing. So I'll go for new notebook, and then once it is there, I will blindly paste the code and run it, and then see. Paste the code and run it. So I'm expecting that finally accuracy will be printed, something like that. So it is running. I think first time run will take some time. I think so. Well, it has to import the libraries. So here I'm getting accuracy 0.977, something like that. 97.77% accuracy it is coming. Obviously, here nothing we can know. Whether this is valid or not, whatever we don't know. Okay, but at least something we know. But what are the ideas you are getting now from here where we can go? I am already getting couple of ideas, but I want you people to think and suggest.
So without using
It is
library,
like a black box thing now. Just randomly I used this thing and it came.
so instead of using library, we can ask ChatGPT to give the exact structure
Ha,
what
so
data
that
entering in the
yeah,
backend.
good. That is one suggestion. Instead of using ready-made library, why not? But even before I go, you are talking about opening the black box, looking inside. But even before opening black box, looking inside, I can try with these things, right? These are some numbers they are given.
Yeah.
Okay. So what is the impact of this? Max depth in the accuracy. Okay. So that is what I'm going to do next. Okay. So right now it is all black box. BLAC black box for me. Uh, it's okay. I want to now understand. I want to understand the impact of, instead of calling n estimators, what was that number of trees? Impact of number of trees on the accuracy. So keeping everything same, I want to change number of trees as 50, 60, etc. up to 150, right? So here how many trees are there? 100 trees are there in the code, right?
Yes.
Instead of 100, I want to go for 50, 60, 70 up to 150, keeping everything same, and plot the accuracy versus the trees. Also, okay, so let's see what it will do now. You are taking the right approach. Experimentation is the best way to understand how random forest behaves. Let me walk you through how to evaluate the effect of any data sets and all. So, what did you say? Accuracy using the iris dataset or any dataset you prefer. We'll talk about dataset later. See, it is simple. It is simple change in the code and then plotting is there. Okay, so let us see that. So I go for, first I will add a text and say uh, effect of number of trees on accuracy. Okay, so and then I will add the code below that, and then I will run it. Now it is running. Interesting. Uh, does it mean that there is no change?
It depends upon the data set also.
But then see, earlier I got 97%, right? But here all are exactly 1.0 because 96, 98, 90. So something happened. See, even at 100, it is giving 1. I think something wrong in the code. Okay, so this kind of things also happen. Something wrong in the code. What you will observe, I think, let us see this. Accuracy may initially increase with more trees. It will likely plateau around certain number. Random forest become more stable with more trees, but not necessarily more accurate after a point. More trees equal to longer training time. So there is a trade-off. Uh,
For all the
Something wrong
values,
in the code for all the values. The
accuracy is 1.
accuracy is 1.00. Can you check? So iris data touch is small, 150 sample and not yet very complex. Training split is 70-30 may randomly with random forest engine. Use k-fold cross validation, updating the this thing. I don't know. Let's see. So I'll simply replace the same code and then go forward. And then let's see. It is not changing the data set. Okay, here also not much difference. Anyway, let's ask it to change the data set. So I'll go back. So see, up to here it worked properly. So that's why I'm going there. And then, in fact, I can even go up. Uh, this was the original thing, right? Sorry. So,
Change the data set, take bigger data.
hmm, please use a bigger data set. See, in fact, the same prompt given again and again will result in a different code. Now it went into analyzing mode. So next, what we'll do is we'll try to see depth and random state, and then we'll also ask it to understand the make us understand the problem statement actually. In fact, I can after this I will directly go for that. Actually, when it says analyzing, okay, some other data set. Let's see. This there is an error here.
So it is completed.
Hmm?
Till now, it is not completed.
Yeah, it is still doing it. Actually, I don't know. I want to use the simple one. Great for everyday tasks. I want to use that only. I want to use the additional advanced kind of things.
Data set download.
Looks like train test split. I think load digits. No download needed.
Data digits data set.
Okay. So it is going with a simpler this thing. No, the same thing came or different thing came. Copy, paste, run. Cell is already running. Okay, I'll go for a new run, new cell.
You can
How do I
delete it.
stop this execution? Here I can stop.
Now the data set is bigger.
See, now something interesting is coming. Accuracy versus number of trees, random forest in digits data set. So some pattern it is coming.
Yes.
Okay, so let us make the steps of 5 or steps of 2 and change it from 20 to 200. Just I mean because the pattern was mostly random, so
So using this, we can decide appropriate
yes,
parameters also
yes, I
instead
think.
of putting randomly.
Huh. So the idea is when somebody, yeah, that is a good point. I see somebody using, in their research work.
Yeah.
By default, initially they start with 100 trees.
Yes. So we
One
can
year they work on developing the algorithm. They never try what happens if it is. Why you have taken 100 trees? There is no answer.
It is like when we do some iterations, the initial x equal to 0,
Yeah,
that should be proper.
yeah, yeah.
Then only that delta t can be calculated.
Now execution time is 43 seconds. I think. See, So basically, it is like a random kind of thing. But generally, we see near to 100, it is increasing. Here, definitely 96% is less. And it plateaus. Remember, they use the word plateau. So it plateaued at 97%, something like that. Now, let us try changing this one. What is that? Split. See, test size is zero point 0.3. So instead of testing more data, I will give zero point 0.1. Okay, then what happens? Let us see. And here I will give it 5 so that so this is kind of even before going in what it is, just trying to understand the impact of different things. Executing, yes. So 97.7 is here, right? I think it did not change much. Test size zero point 0.1 to this one. And what is this random state? Let's understand that. Anyway, this thing we observed, right? What is that? We observed that it will plateau. Sometime back we saw that. Okay, it is also giving a plot here. Explore training time versus number of trees. Yeah, training time also will change. Try real world data set, energy or medical. Understand what happens inside the trees. So now let us go for diminishing returns. After a point, accuracy improves initially as the number of trees increases. So that's what we are seeing here, right? As the number of trees increases, the accuracy is increasing, from 25 to here, and then this one. So too many high trees also not good. Too low is also not good. We have to go for the this. Okay, at least one point we learned until now. I don't know how much time. Maybe we spent about 10 minutes or so. I don't know. Okay, anyway, let's continue. What do we do next? Shall we try to
Yeah,
understand the data and then go into the
you said
black box?
random state. What is that exactly? Random state parameter. We are inputting two
Ah,
key
ah,
parameters. No?
ah,
What's the
ah.
third parameter?
So, here it is. Max depth, max features. I think it is not given here. What is the random state parameter? I'll ask that. By the way, random state is a scikit parameter, is a seed for the random number generator. It's a seed for the random number generator. So that your results are reproducible. Where it is used. Anyway, let me know if you'd like to see what happens when random state is not set. Not interested. Why 42? This just general, random thing only. You get the same output every time. This is helpful for reproducibility in Excel. I think we can remove that random state. Without random state, each time it will give different result. But anyway, I think this is a good concept to know. Okay. You know about this, right? Seed for a random number generator. See, there is a random number generator. Every time it generates random number randomly, but you want to reproduce it. So 10 random numbers. Okay, so I'll just give.
Okay, we are setting the limit of set.
Within
See,
drive,
I'll
it will
just explain
generate
this concept
multiple
now.
random numbers.
So now we are not learning what you call machine learning. We are learning about random number generation. So write a Python code to generate 10 random numbers. Uh, 3 times, then set the seed, then in then set the seed and generate three more times using the same seed. Show the results. 10 random without setting the seed. Okay. If not, I think at least we will learn something. Okay. So I don't want to see the analysis. I don't want get plus. Okay. So here itself it is. See, without seed, first random numbers are 27, 97, 56. Next random numbers are 67. Next random numbers. But here I set the seed, then exactly same it is repeating.
Okay.
Every time random the same function will do like that. So let's go here. Uh, Text importance of
See.
setting or not setting. Seed for random numbers. Basically, this I am documenting. Now add the code, then run it. Now you notice these numbers are different now.
Yeah.
So again I will run it. These numbers are again different, whereas these numbers are same. Now if I change this now, right? What is that? Instead of 42, tell one number.
96.
Okay, 96, 96. This one 78. Okay. So now you can see with 96 I got the same this thing, whereas this one is different. So like that. Okay, the seed concept is clear. So let's move forward. What should we do next?
We'll check the data exactly what is being
Huh.
taken.
So let's talk about data. So can you make me understand and what kind of data set is being used? Digits from scikit. What is it? The digits dataset is pre-rolled dataset in scikit-learn used for classification tasks. It consists of images having handwritten digits 0 to 9, and the goal is to correctly identify which digit is written. Basically, handwriting detection. So 1797 handwritten digit images, 64 features per sample, and the target labels are 0 to 9, 10 classes. That is the this one. Each image is 8 by 8 pixels, grayscale, flattened into 1D array of 64 values. Understood? Each value represents a pixel intensity. 0 is white and 16 is black. So one might look like this one. Its correspond target number might be 7. What type of machine learning task is this? The model learns from the pixel values and it tries to predict one of the 10 digit characters 0 to 9. Why use this data set? Small and clean, challenging enough, useful for algorithms. Visualize few digit images. That is what I wanted to do. Explore the raw data yourself. Try a different data set like iris. Visualize few digit images. It will give Python code for that. See, 8 by 8 grid. So in the 8 by 8 grid, the intensity also will be there. It seems like I can't do more advanced data analysis right now. Oh, that is fine. We are interested. We are interested in basic this only. I'll go for copy, and then I'll go for text visualize digits because that is the data set we are using. Now add code, paste and enter. See like this. So it's a 8 by 8 grid. 0 looks like this, 1 looks like this, 2 looks like this, 3, 4, 5, 6, 7, 8. I think we should kind of zoom out and see or something. See, now it looks right? 0, 1, 2, 3.
Zero.
So if you zoom in, then it doesn't look correct. Okay, I think let's try once again. I think it will randomly select, I think. So this is slightly different or same. So I will ask, uh, does this code display the same plots every time? Since there are many, okay, let's ask like this. Yes, the code displays same plot every time you run it because the data set from site always loads the same data in the same order. It's not randomized. We explicitly set the first 9 samples using digits images one. So unless you shuffle the data manually, you will always see the same 9-digit images in the same labels. Okay, it is shuffling here. So can you give another code to show uh, what you call 9 samples of uh, same same digit, 9 different samples, same digit from the data set. The digit itself can be random, so we will hide the label later for a given run. Set the seed for uh, this random selection. You understood what I'm trying to do, right? I don't want these steps. See, now what I'm doing, I'm exploring the data set. From the data set, I'm printing some, digits. So adding text, explore a particular digit. Adding code, executing. See, I don't even want to see the code because right now, okay, obviously the digit is 6. Okay. Now this seed, if I instead of 42, if I give 4, it may select another digit. Now this selected digit and this thing is there, right? So I will say uh, hide the label everywhere. Let me classify with my eyes. Perfect. Here is the updated version. All labels are hidden, so you can try classifying the digit with your own eyes. See the level of understanding. Okay, so copy and then go for try yourself. Then add a code. So this is 6. Can you guess the digit also? It is 6. Obviously, because the random, seed is being generated randomly. Now I will remove that seed, setting the seed
Seven.
Seven.
7, right? Looks like 7. By the way, these two are not same, right? Yeah. Let's run again. 9. Let's run again. 0. So we are faster or the AML algorithm is faster? Looks like 4. See, in this magnification, we can't see anything. Looks like 6 or thing, but it looks like 4. So then the question comes: what is the accuracy? 100 times. How many times I'm detecting correctly? Sometimes four may be confused with six. Sometimes eight may be confused with seven, whatever,
It
like that.
depends upon the training data, how much.
And the algorithm. See, random forest will give one accuracy, and also implementation of that algorithm. So one fellow will implement with
Supported permission.
and no, even the parameters. See, for example, that we saw training data split, and
While
if they
training,
use the
some may use
wrong
10
parameter,
parameters.
the accuracy will be less. Okay, so it is saying go to new chat. Okay, I'll go to new chat. So here I will say we'll conclude in maybe 10 15 minutes. What should we ask now? So I'll give the context now. Uh, I'm trying to learn about random forest algorithm with digits dataset. I have already understood about the uh, about the about choosing tree number of trees, etc. Uh, Now also and about the representation of data set. Now, now I want to learn internal functioning, uh, functioning of the uh, RF algorithm itself. So here I'm not asking Python code. I'm just asking. Internal working of an algorithm will really help you grasp how it makes a clear breakdown of internal functioning of step by step with image data, handwritten digits. Random forest internal working, conceptual explanation, basic building block decision trees. RF is an ensemble of decision trees. Each decision tree learns simple decision rules from features like pixels in the tree splits data at nodes based on feature values to create pure leaf nodes representing specific classes. Bootstrapping, feature randomness. I think these are all tree building. These are all predict what you call technical terms, right? Voting and averaging. Okay. Putting it together, you input a digit image, say 28 array. Each tree sees the slightly different version of the training data during the tree. Oh, this is each tree sees slightly different version of the training data during different. When you ask for prediction, each tree independently predicts the digit based on the pixel split it learned. The forest votes on these predictions. The digit with the highest votes is chosen is the final output.
Understood.
Each tree will see different part of the, not all pixels will go to all trees. Some pixels will go to one tree, some pixels will go to other tree, and each one is trying to make a prediction, and voting happens. Okay, there is a diagram also. Input digit image, multiple bootstrap samples, train multiple trees, tree 1, tree 2, tree n, prediction, majority voting, and final. Next steps to deeper understanding. Explore how feature subsets are chosen. Study how tree split nodes. Experiment visualizing individual trees. See how randomness. Code to visualize how trees in RS split the digits data. Step by step walkthrough. Okay, or even mini project with data set using SQL every internal step. What would you like to? What shall we do? I think we will see how individual tree splits the digits data. So absolutely, below is the Python code. You will be able to see split rules, pixel well, trains random forest classifier. Okay, whatever. So let's see. Let's copy this code and then What is happening here? Yes, text. How splitting happens. So, and then go for code and then add the code here and then execute the code. Okay, so I was not expecting this. So very big thing came. So here there is a feature called view output in full screen. So I can view the output in full screen. Decision tree from random forest limited depth view. Pixel underscore 21 is less than zero point 0.5, then Gini is zero point 0.9, samples are 1136. That means it is filtering the entire data
Yes.
with respect to pixel number 21. If pixel number 21 is less than zero point 0.5, then like that there are 1136 samples. Then the value, class 2, true, false. Then pixel number 58. So it is going by particular pixels, and then it is doing like this. Okay, so let us see what the here things are given here. So what the code does, loads the digits data set. Okay, that is fine. Trains a random forest classifier, that is done. Extract one decision tree from the forest. So there are 100 decision trees. What is the size it is using? Only 10 trees it is using. Only 10 trees it is using. Out of 10 tree, one of the tree it is taking. Visualize that tree using plot tree from sklearn tree. Displays the tree plot showing splits on pixel features. Good. So what shall we do? Okay, it is 8 by 8 pixel. Each node split is based on pixel values, pixel 45. Colors the nodes show majority class. Class names correspond to digits 0 to 9. Maximum depth 3 restricts the tree size. Run this and you will see tree diagram. Now we understood, right? The maximum depth and majority. See, this side, majority is more here, so this one got the color. Majority more which side and all. Something it is doing. Okay. In the end, it is saying class equal to 4, class equal to 2, class equal to 5, class equal to 9, class equal to 3. It is actually doing classification based on the how. See, here if you see 0, 12, 54, 14, 0, 1, 54 is the maximum. That's why class is 2. So, see here itself you can see out of 1136, 195 is the maximum. Therefore, it is thinking that class is 2. Similarly, here if you see 163 is the maximum. That means it will simply say that the digit is 6. So the more depth is there, see initially it thought it was 2, but actually it is 6. Now further depth if you add, maybe it is 6 or 5. Further depth you have, maybe it is 4, 2 or 5. So the more depth is there, it is adding. So let us reduce the depth. Uh, in fact, this random state I will remove. It will take some default. And where is the? I think depth is default only. I think. So now I'll get a different one. 6892. It's a now I think right side it is going right because I don't know. Genie is more here. Genie is less here. Okay. So at least something. At least you see by looking at one tree, you understood how the forest is going. Okay. Now what I can ask is there are 10 trees, right? Let us increase the trees and ask print the histogram of like voting they are saying, right? So I want to visualize the voting. That means how many trees voted for which class, which digit. Okay, so let's do that. Okay, so now increase the number of trees to 100 and visualize, and I want to visualize the voting. How many trees voted for which digit? See here, the idea is the similar looking digits will get similar votes. That is my thing. Great. Here is how you can train a random forest with 100 trees and digits. Predict the digit for a sample. Count how many trees voted for each. See, it is taking one sample. The sample can be four, five, whatever. Visualize this voting as a bar chart showing the vote counts per class. So sample index is zero. I think it is testing for zero. Okay, so interesting. So let us copy. So here I'll go for text. Visualize the voting. Okay, code I will add and then I'll paste it and run. So look, it is working perfectly. So I don't want perfectly running. Let's change the digit to 7. So I think we'll reduce the number of trees. Okay. So instead of 100, let's keep only 50. So that the accuracy will reduce, and here it is perfectly going to 42. Actually, this random state also I will change, and then the digit to recognize is 8 now. See, 8 and 3 are looking similar. So those one tree which is looking maybe on the right side of the, thinking that it is 3. Let's run again. Sometimes 0 also came up. I think we will reduce the trees, and we'll reduce the. Actually, I want to how to reduce the depth. I want only depth of 2 instead of 3. I think I'm reducing the depth. So here it is setting the max depth. So by reducing the max depth, I can. Where is it? Here. So max. So these all. This is again Google Colab, because I downloaded the scikit. It is showing all the parameters what I can set. GV max depth. Anyway, now I reduce the depth. See, now the accuracy reduced. Okay, to predict the number 8, it is not able to do it actually. Number 8 got only 6 words. Now let's increase the what is that? Increase the estimators. Let's make it 500 estimators. So now again, the depth is very important here. That's what we came to know. Let's make the depth 3. So still it is not working. Depth 4. Now
No.
digit 8 is being detected correctly. So, but still, I mean, we understood something. Now you realize the amount of knowledge increased. We understood the impact of number of trees and all that. I think let's display the. We can display the person, but then visually we can see, right? So, what if I make depth 5? Okay, here saving is not running. See now 279 versus 63. So by default, how much depth it will take? Depth 10. I think they are saying, right, overfitting problem. You know, too much depth will be overfitting actually. So yeah, let's go back here.
Sir, you
May
gave number as 8
I gave the number to detect as 8. You want to try 4?
because 8 it will detect as all
Because
that
huh,
LED 7 segment display.
huh.
But 4 should not be detected as other class. 8 can be detected as all other
So you
classes.
are saying that the accuracy will be more for less for
Less for
8.
8
Yeah. So let's good, very interesting. So let's verify that.
because
Okay. So
if you off one
so
LED,
now I want to check which letter can be detected. Now I want to check what is the accuracy for each letter. For each letter, can you give the code for this? So we'll plot a bar chart. I think this is the last. We'll stop after this because it's almost 8. So immediately I got the code, copy it, and then go for adding text. So digit versus accuracy. So your results are here. So 8 is actually 1 is
Why?
minimum.
Okay.
Okay, so I think not all digits are displayed here, but anyway we can work
Yeah.
out. But 0 is most accurate. Let's play with these values. Maximum depth is only 2. Okay, so I have to increase the depth to 5. Random state I will remove. I want to get generate random every time. See, it is more or less accurate for all. If I increase the depth, almost same it is coming for all. So let's keep the depth to 2 only, and then number of estimators 500. Yeah, so your prediction is correct. 1 and 8 are coming less, whereas all others are coming
More.
more. Probably because 1 means some people will write towards right, some people will write in the middle, some people will write in the left,
Yes.
and some people write slant. So, yeah. Whereas the other letters. So, which one is the having the 0 is having the
0 is
maximum
having
because in
because
between.
anyway you see it is 0.
Yeah, left, right, top, bottom.
So, we'll ask.
What is the reason for 0
Uh,
to be more accurate?
I noticed that in general the accuracy is low for 1 and 8 and max for 0. Can you explain why? Good observation. It's quite common to see digits like 1 and 8 having lower accuracy compared to digit 0 in handwritten digit classification. Here are reasons why. Visual similarity and ambiguity. Digit 1 often looks very simple, just as a vertical stroke or a thin line. Can easily be confused with 7, 4, or 9 if handwriting is sloppy. Digit 8 has complex shape with two loops, but sometimes handwriting varies greatly. Loops may be disconnected or strokes can be messy, often confused with 3, 5, or 6 in poor handwriting styles. Digit 0 has a very distinct enclosed oval or circular shape. It is visually quite different from most of the other digits. The clear pattern makes it easier to. Class imbalance and sample variability. Actually, now I will test the ChatGPT. See, what is happening is, whatever I ask, it will say good observation. It is.
No, you wrong answer.
I'll just pull the leg. What I will do, I notice that general accuracy
No, sir. If
is
you
high.
again, if you give to same chat, it will
No, but
distinguish.
I am changing the old one. I'm not going to new chat. I'm changing the
So just
old one
reverse high for 8 and low
and
for 0.
low for zero.
No, no, it will
Can you
detect,
explain
sir.
why? Huh?
It will
No,
detect.
but see this thing it will not consider.
It will remember, sir, in its history.
Let us see what it will say. Nice observation. High accuracy, distinct. Same thing it is saying.
Initial, it is
So,
like how we write in
so
maths. In
yeah. So here
between
is
steps are different, hence proved.
so here is where ChatGPT can make mistake. Check important info. See cookie preferences. Now what I will do, I'll take this thing. Maybe we'll go for a new chat and then try. Actually, we are diverting. So let's go back and summarize this.
We will
Actually,
try in new chat, sir. Once.
okay.
We'll see what it gives.
So new chat.
But we have to give like we use random forest.
When using AI ML technique, TCHNIQUES.
Simple vertical lines.
Harder to confuse with others. Digit zero sometimes resembles other digits. Now what I will do, I will.
So it will just make sense.
This is the problem. So now what I will do, I will say you yourself said like this. Now why are you changing like that? I will say. But I think I deleted that thing, right?
No, sir, it is there.
No, I changed the thing, right? Digit recognition accuracy. Copy. Under this only when using some other some other AML techniques. Can you explain? Sorry, I have to stop this. Here I have to make accuracy is low. So we need to be careful, like more complex, simple closed. Your above two answers are
Oh
contradicting.
shit.
It will say because above two prompts are contradicting. So it is now going, big explanation. Anyway, so I think if I go back here, is there a way to make this available? I think you can go for share and then see all the codes are available. Anybody will be able to run. So what I will do, anyone with the link, and then I will copy this link and then say done. So anybody can open that link and then keep your cursor here and then run and change the parameters, run and look at the details and all. So this will be available in the description.